Okay guys, here we got the eccentrically loaded connection. This is our scenario from November 2020. Okay, yeah, November 2020. The figure below shows an eccentrically loaded connection. The connection subjected to a load of 32 kilonewtons at 375 millimeters from the center of the steel column. They want us to calculate the diameter of the bolts required to hold the connection in place, and then use the shear stress value of 175. It's pretty straightforward. What I want. Normally 11 to 15 marks for this question. Okay, let's jump straight in because it's not a long story, this one. So okay, determine the vertical load. The vertical load is also called the F direct, but okay, we'll get to that one. What it basically is the eccentric load divided by the number of bolts. So here we have bolt number 1, bolt number 2. This is under the center of the steel column. So bolt 1, bolt 2. There's the span between our two bolts. This is the span from the center of the steel column to the force. The eccentric, yeah. So our eccentric load divided by the number of bolts will give us our F direct of 16 kilonewtons. And then the distance from the center to the furthest bolt, which is basically as this distance divided by 2 to get to the center here, which is going to be 235 divided by 2, which gives us 117.5 millimeters. Okay, so here they want the direct load on the bolts due to imposed load. This formula, I don't like this formula, it's not as clear, but I will show us this formula over here. So this is basically just moments, and we can all do moments at this point. So clockwise, just focus the camera. So clockwise moments equals the sum of the anti-clockwise. So clockwise we got the force times the distance, and then force times distance times our ft as a subject of the formula. In this case, we'll see why it's a subject when we come to the resultant here at the bottom. So okay, so here we got the 32, and it's going clockwise. It's going clockwise times the distance, the perpendicular distance of 375. Okay, then for the anti-clockwise, we have our two bolts times the distance of 117.5, which is the distance between the bolts, and that will give us our 51.06, because then we will divide on that side and then to get our ft alone, and then our F resultant, which is our direct load now in this case, is the ft here plus the F direct. And the F direct is here on top of 16 kilonewtons. We'll add that and get our direct load on the bolts due to the imposed load. Okay, so then now we want the bolts size. We must determine the bolt size, and that's our formula over there. And we can get that. So our stress is 175 that they gave us, and then over here we have kilonewtons, so we must convert to newtons. So we are timesing by 1000 because it's megapascal, which is Newton millimeters, and then the 2 newtons will cancel. We're left with millimeters squared, and then that's our answer over there. And then we're not done yet. We must now go to this formula here, the diameter of the bolts. This is our formula. As pi diameter squared over 4. We're going to do subject of the formula, cross multiply everything, and then we are going to insert our area, and then so this is our stress formula for the area of the stress. Then we're going to substitute that there, and then we're going to just put in a formula and then get our final answer as 22, and then we're going to round that off to 25. If it was 27, we'll make it 30. If it was 31, we'll make it 35. And then we have 2 bolts, so we're going to just say therefore, because there's normally 2 marks at the bottom, so use 2 M25 bolts that we rounded off from that 22, and then that is our eccentrically loaded connection.